In this lesson, we will talk about simulations. So we're back to M&Ms because I love M&Ms. They are delicious. And I have a bag of M&Ms, and we'll just say that that bag contains 20% red, 10% yellow, 30% blue, and 40% green. And I want to answer the following questions. If I draw 5 M&Ms from the bag, what colors will I draw? And how many M&Ms must I draw until I have one of each color? So obviously I could actually open up my bag of M&Ms and answer those questions. And in this case, that wouldn't be very difficult to do. Open a bag, start counting M&Ms. Easy. Instead, let's talk about how I could simulate this with a random number. So in this case, I had 20% red. And notice that I am allowing my random numbers from 00 to 19, which is actually 20 numbers, to represent red. There were 10% yellow, and notice from 20 to 29, that's 10 values. Blue goes from 30 to 59, there were 30% blue, and then 60 to 99, there were 40% green. And notice that I've equally spread out my numbers to make them represent the same percentage that I had in the bag. So that's very, very, very important. Now, I do want to point out at this point that because they were nice whole numbers, 20%, 10%, etc., I could have said, let red equal 0 and 1, let yellow equal 2, let blue equal 3, 4, and 5, and let green equal 6, 7, 8, and 9. And then I would just take the digits one at a time instead. I'm going to show you using 2 digits because most of the time we're going to end up using 2 digits because you're going to have numbers like 23% or 15% or 37%, and therefore we would not be able to use 1 digit. So here is a random number table. This is a line from the random number table. And I want to show you how we would use this in a simulation. So I'm going to use the numbers and I'm going to take 2 digits at a time. 2 at a time because I have set up my numbers to be 2 at a time. And then I'm going to record the resulting color for each. And I'm going to continue until I have at least 5 draws and 1 of each color so that I can answer these questions. So 47 corresponds to blue. 35 corresponds to blue. 24, notice I'm taking 1 from each of those, so 24 corresponds to yellow. 28 to yellow. 53 to blue, so I still haven't had my 10 or 1 from each color yet. 42 corresponds to blue. 90 corresponds to green. 39 corresponds to blue. 75 to green, and 4 to red. So now I'm going to stop. So even though I have all of these other numbers, I'm not going to continue because all I wanted to do was answer these 2 questions. So now if I draw 5 M&Ms, what colors will I draw? Blue, blue, yellow, yellow, blue. So I'll draw 3 blue and 2 yellow. And how many must I draw to have 1 of each color? I drew 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, that's just based on my simulation, and I could simulate this again and again and again very easily. And the best thing about simulations is it doesn't cost me any money. So I don't have to actually go buy 100 bags of M&Ms and check this. I can just simulate it 100 times using random numbers. So I want to talk to you about the parts of a simulation, and then I want to talk to you about the steps, because I will ask you to actually do a simulation of your own on your case study for case study 2. So a simulation is essentially a sequence of random outcomes that models a situation. So again, we just did part of a simulation, and that was simulating pulling M&Ms out of a bag and answering those questions. So there's 4 major parts. The first is the component, and that's the most basic event. So not that I'm using a random number, but that I'm drawing out an M&M. So it's the actual event that we're simulating is the component. The outcome is the possible results. So in our case, that was possible M&M colors, integers 1 through 6, etc. if you were simulating rolling a die. The trial is the sequence of events you want to investigate. So if we're studying the number of heads resulting from 5 tosses of a coin, each set of 5 is a trial. So it's not that each flip of a coin is a trial. Each trial is however many that you're going to do. So in our M&M example, we would say that for question 1, a trial would be pulling 5 M&Ms out of the bag. If we were doing question 2, where we were looking for how many do I need to pull out before I have one of each color, then that would be the trial. The trial would be, M&Ms pulled out until one of each color. Response variable is what question we're trying to answer. So how many heads did I have in 5 tosses? How many M&Ms to have one of each color, etc. There are 7 main steps for a simulation. So the first is to identify the component to be repeated. We just talked about what that was. Number 2, we'll explain how we model the outcome, and we'll explain how we simulate the trial. So typically, 2, 3, and 4, we kind of smush all together into a sentence. We're going to do them as separate parts in our first example together. But essentially, I'm going to explain how I'm going to model the outcome. So that's where I'm going to say, I'm going to let 0, 0 to 1, 9 represent yellows, or whatever color I used. So I'm talking about that. I'm talking about how I'm going to simulate the trial, basically stating I'm going to choose 5 M&Ms, or I'm going to keep drawing M&Ms until I get one of each color. I'm trying to determine, that's the response variable, how many M&Ms I need to draw before I have one of each color, etc. Then we're actually going to run several trials. Most of the time, you're going to have to come up with those random numbers yourself. For the examples that we have together, you're using my random numbers just for simplicity's sake. Then we're going to analyze the response variable. Usually we use a table of some sort to essentially make our results easier to understand. And then we're going to state our conclusion in context in words. So whatever question I was trying to answer up here, the component to be repeated, or etc., that's my conclusion. So it would take this many M&Ms to have 1 M&M of each color. Or in a bag, when I choose 5 M&Ms, these are the colors that I would most likely get. So let's take a look at what this looks like in an example. So in 2015 World Series, the Kansas City Royals played the New York Mets. The first 2 games were in Kansas City, the next 3 in New York, and the last 2 would have been in Kansas City if they were necessary, which they weren't. The winner, in real life, they weren't. The winner of the World Series is the first team to win 4 games. Over the course of history, the home team wins 55% of the time, so that's important, which of course means the visiting team wins 45% of the time. So now we're going to simulate the World Series. So what is the component to be repeated? Well, we want to know who's going to be the winner in a World Series game, so that's what we're going to keep repeating. So how will we model the outcome? This is important. I know the home team wins 55% of the time, so how am I going to model that? Well, I would probably say 0, 0 to 54 is going to represent a home team win, and then 55 to 99 would represent a visiting team win, okay, or away team. And then how am I going to simulate the trial? Again, typically I'm going to put all of this kind of together into one sentence, but I will generate 7 2-digit numbers from 00 to 99 in Minitab. You could use StatCrunch. I used Minitab on this one, so I kept it Minitab, which is very similar to StatCrunch. I will record the winning team until either team wins 4 games and record the winning team. I will repeat the process for 5 trials. So notice everything that I've covered in all 3 of these steps. I've said the component is to win a World Series game. I'm modeling it using these values. I'm going to tell you that I'm using generated numbers from Minitab. I'm recording, and notice these are 2-digit numbers, which matches the 2-digit numbers from here. I'm going to record the winning team, and then this tells me when is the trial over, until either team wins 4 games. So once a team wins 4 games, the trial is over. And then I'll record the winning team, and then I talk about how many trials am I going to do. Then I'm going to determine which team will win the World Series. That's the response variable. So again, typically I would put that in with the rest of the first 4. And now I'm going to actually run 5 trials. So here are some values. And again, I generated these using Minitab. You could easily do this as well using StatCrunch or your calculator. So these are the values that I'm going to use. And I want you to notice how I'm modeling my solution. So I'm saying 19, that's a home team win, which was Kansas City. 50, which was a home team win, because remember it was 0-0 to 54 was home, and 55 to 99 was away. So 92, that's an away team win, but now remember Kansas City is actually switched to the away, because remember it's 2 at home, and then it's 3 away, and then 2 back at home again if you get that far. So in this case, this was the home team win, KC is home. Now we switch because KC is away and New York is at home, and we get 92, which was an away team win, which is now Kansas City. So Kansas City wins again. And then we get 87, which is an away team win, so Kansas City wins again. And now my trial is over because KC has won the World Series. Then in trial 2, I do the same thing. So 68 is an away team win. Well, now that's New York. And then we get KC, New York, etc. So notice I'm being very deliberate about who's winning, and then I'm going to summarize my results. Now, quite often I will put the table with the values and the table with the conclusion all on the same table just for sake of simplicity. But this was the actual conclusion. The first trial, KC won, New York won the other 4. Now, what's my conclusion? My conclusion is not that New York will probably win. My conclusion is that based on my results, Kansas City will win the World Series 20% of the time. Now, where did I get that? Well, I had 5 trials, and 1 out of 5, KC won, which is 20%. I could have also said, based on my results, it's likely that New York will win 80% of the time. So again, notice that when I'm writing my conclusion, I'm not just saying, well, New York won most of the time. It's really important that you find the average based on however many trials you actually performed. So on our next video, I'm going to give you a chance to try 2 of these on your own using numbers that I've generated for you.